square. Okay, we have so far shown that using both the methods, this is the method where we tend to write the given fraction into maximum number of fractions. So we have done it like a over x plus 2 here, and then plus b over x minus 2, and then c over x minus 2 whole square. We got the values of a, b, and c. So these are the three fractions that we're getting. Now, in this second method, where we try to write the minimum number of fractions, and we have taken this x minus 2 as a quadratic, and we don't want to further write this as a product of 2 and splitting this into two fractions. So we just kept this in the numerator, like this was written as a over x plus 2, and then bx plus c over x minus 2 whole square. So we got to this, like we got this b minus 3 over 16, c 9 over 8, and after simplifying, we have got this form. Now I have to convince you guys that uh, these two fractions are the same as this single fraction. In other words, I have to prove to you people that these, if you sum up these two fractions, you should get this minus 3x plus 18 over 16 into x minus 2 whole square. Let's do that quickly. I'm just going to sum up these two fractions over here. So what do you think? What is the LCM of these two fractions? Come on. The LCM of
16
these
bracket x minus 2
16 into x minus 2 whole square. So the LCM would be, let me change a color here so that you know that we can sum up these two fractions. So the LCM is going to be 16 into x minus 2 whole square. This minus 3 will be multiplied by x minus 2 because this is lacking x minus 2 square. There is a 16 with this, but there has to be a square, so we need to multiply this with x minus 2. Now guess what would be this 3 multiplied with? 3 will be
It
multiplied
will be
by,
divided with 4, so it will stay the same.
4.
because we want to have this as 16 into x minus 2 whole square, so this is 4, okay? So let's simplify this. This is minus 3x plus 6, and then you have plus 12, that is 16 over x minus 2 whole square. So don't we get this fraction, which is minus 3x plus 18 over 16 into x minus 2 whole square. So I have tried to convince you people that even if you split your fraction into three fractions, like this b over this and then c over this square, or you just write one fraction, that bx plus c over x minus 2 whole square, the result is the same. But now let me tell you, you will be needing the maximum number of fractions when your next part of this question is about binomial expansion. And you will be required to write minimum, I am saying opposite. You will have to write the minimum number of fractions when you have to go for the binomial expansion, and you will be required to have maximum number of fractions like this, like we have these three fractions over here, when your next part is about integration. You will be doing that soon, inshallah. But in this chapter, you will have to learn about this binomial expansion as well. So for that purpose, you will have to write minimum number of fractions. And I'll tell you there that why do we need to write minimum number of fractions. Now, suppose this is a very frequently asked question, that let's say you get a question in exam that you have to write the partial fractions for this. So which method is correct? So both the methods are correct. If someone is going to write it like this and someone writes like this, they will both be getting full marks. This is totally up to you. But remember, this question on partial fractions it is rarely, a question that where you have to just write the given fraction into its partial fractions. There is always a second part where you have to convert, where you either have to go for the binomial expansion or you have to integrate. So you have to decide accordingly that how many fractions you will you need to have. Okay, so this video is up to here, where I've tried to convince you guys that when there is a quadratic expression, we have to keep the linear, I mean the numerator, a linear one, but this can be done in these two different ways. Okay.